In section 1.3.2, we're solving quadratics with the square root method, which means that we can do that when there's no linear term. So that last problem from the factoring, we could have alternatively done this square root method. So our quadratics now look like this, where there's no b term because there's no linear term. That center term, that the b was in the ax squared plus bx plus c equals 0. There's no b term because that b term is linear. So it looks a little different. It only has two terms. A is not equal to 0 because they want it to be a quadratic still. If a was 0, then that first term would just drop out. It would just be a constant. It would just be 0. So when we have that, we can use this fact that when I have a perfect square, I can just take the square root of both sides, plus or minus the square root of both sides to solve. So if I have ax squared plus c, I can just subtract c and then divide by a, and then take the square root. Let's kind of do that generally. So I'm just going to zoom here and say if I had this general equation, I could subtract c from both sides and get ax squared equals a negative c. And then I have to divide by a, and I would get ax squared equals negative c over a. And I don't know if c is a positive or negative number, so negative c, I don't know if that's positive or negative, but when I take a square root of it, I take the square root of both sides. On the left, I get just x. The square root of x squared is x. And the square root of negative ca might be positive or negative. If it is negative, which it might be in some of these problems that we're going to see in a little bit, we're going to deal with that by the imaginary number I, which is defined as the square root of negative 1. So when we have a square root in the negative, we're going to deal with it by pulling out that imaginary number, which we'll learn a little more about later. And that imaginary number I is just defined as the square root of negative 1. So let's look at number 26 to start this example. So remember, the idea is to get the squared term alone and then take the square root of both sides. So we want to get it, the goal is to get it in the form, I'm going to write this in red. The goal is to get into the form of x squared equal to something, so you can take the square root of both sides. That's our goal. Okay? So let's look at number 26. I need to get the square term alone. Oh, actually, I'm going to do that in orange. So I'm going to subtract 16 from both sides, so I get v squared all alone. And I get v squared equals negative 16. Now I have v squared alone, so that means now I can take the square root of both sides, and I get, on the left, I get v, and on the right, I get plus or minus the square root of negative 16. Don't forget that negative on the 16. And I told you before, we're going to deal with that negative by using the definition of I. So we're going to use this definition to deal with that. So we got v equals, and I can separate that negative 16 into 16 times a negative 1, which is, and with a square root, I can split up factors like this. And now I have plus or minus, the square root of 16 is 4, and the square root of negative 1 is I. So I can't express plus or minus 4i as my final solution. I just want to recognize, though, that's really two solutions. So that's actually positive 4i and negative 4i. That's two different solutions to this equation. So if I did want to check my work, I'd want to check a positive 4i and a negative 4i. I'll go ahead and do that, actually. So if I want to check a positive 4i, plugging that in, I get 4i squared plus 16. And I want to check, does it equal 0? So let's see, 4i squared, that's 16 What's I squared plus 16? I squared, remember I is defined as the square root of negative 1. So if I were to square that, then the square root and the square cancel, and I get I squared equals negative 1. So that means 16 times negative 1, which is negative 16. So that does equal 0 and check. And notice if I plug in the negative 4i, I get the same result because negative 4i squared plus 16, because the square, when I square a negative, the negative goes away, so I get 16 I squared plus 16, which is negative 16 plus 16. So both those answers are verified and checked. So I'm going to move that solution over there so I can have some space to do my next example. So let's look at number 30, getting a little more complicated now. So I don't have the variable alone squared. I have this whole expression squared. So, but I still have the square isolated. So the idea is to get the piece that is squared to be isolated, because that way I can take the square root of both sides and I get 4x minus 1 equals a positive 16. And then I can solve for x. I'm sorry. What did I do there? Sorry, 4x minus 1, taking the square root of both sides. So square root of that, the square cancels. Square root of that one, I get plus or minus the square root of negative 16. And we saw the square root of negative 16 is plus or minus 4i. We saw that in the last problem. Now I can add 1 to both sides and get 4x. I'm going to go ahead and show that work actually. So I'll add 1 to both sides and I'll get 4x equals 1 plus or minus 4i. And then getting x by itself, I'm going to divide both sides by 4. On the left, I end up getting 4 divided by 4 is 1, so I get x. But on the right, notice that this is a very common mistake is to want to cancel out those 4s. But I can't do that because there's this 1 here. So I can only cancel those factors if it's in every single term of the fraction, both the numerator and the denominator, every term. There's no 4 in that first term of the numerator, so I cannot cancel the 4. So that means this is my simplest form. And I just get 1 plus or minus 4i over 4 as my final answer. And I can verify that. I'll just go ahead and check my work here. So if I do 4 times x, which is 1 plus 4i over 4, minus 1, all of that squared. I'm just copying that original equation and plugging in the fraction for x. Let's see, do I get negative 16? Well, let's see. In this fraction, these 4's will cancel. When I multiply 4 by that fraction, the denominator, it cancels the denominator. And I get 1 plus 4i minus 1, all of that squared. The 1's cancel, 1 minus 1, and I get 4i. Oh, where'd my squared go? And that is 4i squared we found over here. That is 16, and I squared, remember, is negative 1. So that equals negative 16, which is what I wanted it to equal. So yes, that solution is good. Okay, last example, we have number 32, and again, we have the squared term by itself on the left. That means I can just take the square root of both sides, and I get The square and the square root cancel, and I get 3x plus 8 on the left. And on the right, I have plus or minus the square root of 12. The square root of 12 can be split into factors of 3 and 4 because the 4 is a perfect square. So I can reduce that radical by taking out that perfect square of 4. The square root of 4 is 2, which leaves me with 2 radical 3 is a simplified radical. And on the left, I just have 3x plus 8, 3x plus 8. All right, so now that I have that radical simplified on the right, there's not a whole lot of, there's no like terms here to combine. So all I can really do is subtract 8 from both sides to isolate that x. And I get 3x equals plus or minus. Actually, I'm going to put the, I like putting the plus or minus in second. I got that negative sign in front, which I don't love, but that's okay. Either the negative or the plus or minus has to be in front. So I'm going to write it like negative 8 plus or minus 2 radical 3. And then to get x by itself, I need to divide both sides by 3. And I get, on the left, I get x, and on the right, I can't simplify this at all. This is as simple as it gets. So I'm going to write negative 8 plus or minus 2 radical 3 all over 3. I really can't simplify that any further. The order of the negative 8 and the plus or minus 2 radical 3 does not matter. So you can write that a couple different ways. But here is my final solution for 32. All right, so there's my 3 examples for solving with using the square root method. Remember that, actually, let me ask you the question. So which of the following can be solved using a square root method? So I'm going to give you a second to answer that. So if you said B, you were correct. You cannot do A because you have this x on the right. If you take the square root of both sides, you're still going to have an x under a square root sign. So remember that you can have no linear term, or in terms of this general form, no B. So there's no B term. So the square root method can only be used when there is no linear term in the quadratic equation. So there's 1.3.2.